guys, this is Josh. Quickly on our part 4, lab 104 for DESD. Okay, so the outcome of this project, the objective is to display your 7-segment decoder, 7-segment display. That's what we want to do. Okay, and what the alphabet, the characters want to display, we are using a DE12 by the way, characters want to display are DE2 and blank, okay, and blank and nothing, okay, so that's what we want to display. So the code for that is this, okay, this is the code for it. This is just basically the description, the port description. Well, this is a code for it, not necessarily the code, but you would understand why I said that in a bit now. So this is the part you need to understand. You might need to defend for John when he asks you in the class. So this is my own comment. You don't have to, that comment doesn't, once you have a double iPhone like this, a comment of course in your VHDL. Okay, so this 00, how did this D become this? Okay, well, just ignore this, okay? So we'll focus on this. So how did D become this? That's what I want to explain. That's the main thing you need to be able to understand. Now you need to listen closely, please. So to have a D, which is 7-segment display, you need to have this. If you want to write a D, write it this way. This way, right? D, right? Okay, so for that to happen, you need to have this on, this on, this on, this on, this on, okay? But this 5 and 0 need to be off. All right, let me do something quickly. Snipe this, okay? So you need to have that on for your D to display. Let me do something, just hold it. Okay, so you need to have all of that on for your D to display. 1, 2, 3, 4, and 6 need to be on, but 5 and 0 need to be off, okay? Now, and of course, those 7 bits is what came about this 7 bits here. 1, 2, 3, 4, 5, 6, 7, okay? So then why is it like that? Okay, let's see what we have. All you need to do is just to write it out. For example, for your D, your 0, first you need to invert, okay? The name I've called this is something like double inversion. That's just my convention of describing it, explaining it to myself, okay? So first, for which is explained here anyway, by the way. So for you to turn off this 0, the value you put there is a 1, okay? For you to turn this on, you use a 0, okay? Then your 2 on is the opposite, 0. 3 on, 0. Don't forget we're writing a D, okay? So your 4 needs to be on also. This is 0. And your 5 needs to be off, right? That's a 1. And your 6 needs to be on. That's a 0, okay? That's your first inversion, okay? Then the second inversion, what I call the second inversion, that you use, so to speak, to neutralize this inversion you've done, is to then write this out in the opposite order, like that. 0, 1, 0, 0, 0, 0, 1, okay? So just watch that. Let me just minimize this somewhere so it's not too far. So check this out. See what we have there? Comparing it to this. So this regular stuff, first inversion 1, 4 zeros and 10, is what I wrote as my comment, so I can understand how that came about. Okay, I wrote that as my comment here. And then when you then write this backward, is written this way: 0, 1, 4 zeros, then 1. So it's those two inversions that you put into your program to make this work, to display your D. Use the same principle for your E, use the same principle for your 2, and for your blank. Now there's a little, so if you use the same principle, you get how all these came about. Okay, so I think this is what I'm going to post on Telegram now, I think, hopefully. And maybe on the YouTube description, but YouTube description is not accepting this bracket, okay, this angled bracket. All right, so yeah, so there's a little, well, I got an answer from Debbie, okay, code from Debbie, a code from Felix, okay, and the reason why I'm going with Felix's code for this. Now, both codes are going to run, okay, but they're going to do different things, okay, but I think this Felix's code is probably going to do better. Now, when using our two inversions like we just described, if you have a 1, 1, 1, 1 like this, what does it do? It turns off all of the 7 LEDs, okay? It turns everything off, and of course, when you invert 1, 1, 1 backwards, it's still the same 1, 1, 1, okay? All right, so that gives you a blank that you want here, okay? But the Debbie solution, what she did was such that to give you a dash. Okay, everything else was off except this 6. Okay, and I reckon that, well, a blank is not a dash. Okay, that's a dash. Okay, a dash is not nothing, but what they want you to display here is nothing. So I think 1, 1, 1, 1 is probably a more correct answer too. And then there's one other line not very correct from this convention that we used in Debbie's code. Okay, it's going to run, but it's not going to display. It's going to display something weird like 5 and 4 and 6 on. That's, I don't know what alphabet that is. That's not a character, at least not English or alphanumeric. Okay, so now there's a very interesting twist to this that you might want to get to listen to. Now this also, because we're currently at lab 4 for DESD, this also is the same principle that we're going to be using in our SoC Lab 2, okay? By the way, I'm still at Lab 1. I didn't pass. I have not done my Lab 1 of 3 yet. But I think I understand the principle. So this is this material, okay, Lab 2 for Alex. This is for John. Okay, this is for Alex. So, well, this is the last page of this, okay? So now watch, it's the same principle when you want to write your display your number for Alex's project next week, probably lab 2. Okay, so it's the same principle. Now of course this is for D light 10, but it's very similar as you might have noticed here. Okay, this is D light 10, this is display way displays, and D2 light 10 light and D2 115, very similar. So it's the same principle here. So watch this. To display a 0, he literally writes it out. Now watch this. It says to display a 0. We're at SoC Lab 2 now. Excuse me. To display a 0, you need to have, now there's no inversion in this writing. Okay. To display a 0, you need to have A, B. Now it's called A to G here. Its name is the same thing as 0 to 6 here. Okay. So to display 0, you need to have A, B, C, D, E, F, and G off. That's what it just said here, okay? No inversion, okay? But he implemented the double inversion straight up without any intermediary transition. Straight up, boom, like that, okay? Unlike here where I explained it to you, first inversion, second inversion to neutralize it. It's just 2 inversions. And of course, this 8B is 8 bits because this is 7, and then this is 8 decimal point, okay? So this 8B is specifying 8 bits, and this 1 is for this first decimal point. And for this SoC, your 1, this decimal point is off when you are still between 0 to 9, but when you get to other characters, then you turn it on, okay? So that's how it works, yeah? So to display 0, all the bits need to be on, and the G, the middle one, needs to be off, okay? That's how you display 0. So double inversion, first off, it changes this to 0, 0, 0, 0, 0, 0, 0, and 1, and then erode it the other way around, which is 0, 0, 0, 0, 0, and 1. Okay, and then this means the decimal point is going to be off. Don't forget it's inverted. This is 1, so it's going to be off. And this 8b is the 8 bits. Use the same principle, you can fill all of this out. Okay, and here you're going to begin to turn on the decimal point, okay, to show that you've gone beyond 9 or beyond 10, basically. Something like that. So that is the same principle for your lab 2. So that is like a combo, basically. One stone killing 2 birds, yeah? So, yeah, so that's your lab 2, okay, for Alex, and that's your part 4 for, what was it now, for John, okay? Now, watch this. This is the third thing you need to notice. Now, just pay attention, please. When you go from here and you copy this code I'm going to send to you, a code, my code, any code, and I've opened this already. We know how to do that. I've opened a new whatever, part 4, and I paste that here. Okay, I need to save it first. I usually save at Quarters Telegram. I hope I don't have something there already. Well, new project, yeah. Yeah. Part 4. Yeah. Existing, open Quarters, delete existing project, continue remote project, return to, I think. So, are you sure you want to remove setting for project part 4? Yes. Let's hope that works. I hope I've not messed something up. Okay. But, so, okay, so let's run this. Okay, so we're running this right now. Let me open the messages and the tasks. All right, so when you copy and paste this, let's see what is going to happen. This is the third part. You need to listen to this. When you're copying and pasting, so it's going to generate errors after 20 seconds thereabout. Okay, yeah, that's errors. Okay, so now you would discover it's going to point you to this line. Okay, and the reason is because you just did a copy and paste. If you cut this out, okay, and you literally type literally the same thing, it changes from red to purple. So you see that's purple now. Okay, so you do the same thing for this, do the same thing for this, for this, for this, and run it again. It should run. Now I tried to paste it on text, and just for aesthetics, let's make this a line. I tried to paste it on text and pasted it here. It's still the same issue. Okay, it's not gonna run because of that. That cost me a whole lot of hours. Well, then some people, I think Debbie's solution says 15 to 14. Felix's solution says 17 to 16, but as long as you define just 2 bits, I think you're good to go. And to know what bits you define so you don't keep touching your board, you know where to go. All right, so let's run this again. I think it should work this time. So once it's 20 seconds, it's still running, and you see this is having good progress, then we know that it's good to go. So let's open the VHDL. So let's see, 12 seconds. So it's 20 seconds. We still have progress. So I think we've gone past that term, the error stage. So if you copy it and paste it directly, it's not going to go through. You have to type. I'm laughing because I remember my conversation with Debbie. Because I was too lazy. I didn't want to type, you know. So, but she was just laughing at me. I didn't know she had a trap. So this is 0 error 17 warning, so it's going to go through. You have to type that out. So I don't even know if she knew that anyway, but anyway, that was that. So this is the code. I'm going to get this code across. So summary, quick summary. This lab 2 is to display this. To do the display, you understand you want to write a D, write a 2, write an E, whatever, and then you literally write that first inversion, okay, and then write it backwards as a second inversion. So for you to understand it, the way I did it is to write, let me show you in Quarters itself, is to write out this first, okay, This first inversion, write it backwards, second inversion, then you have this, okay? And then all this, most of it is just stories, whatever. It's just same thing for most projects. Then this is going to be a 2-bit. This is going to be 6 to down to 0 is basically this 6 to 0, okay? 7-bit stuff. Okay, so whatever you define here, you see it's highlighted here, and here. Is what you should define in every other place too. 14, 14, 14. I can make this 1 to 0 is still going to run. Then I think, yeah, we remember how that matches just this guy, okay? Double inversion without intermediate transition for SoC for Alex. For lab 2 next week, I think. And then finally, don't just copy and paste. You need to type it out. It's going to give you an error. Okay, you have to retype this colon. Anything else? Yeah, I think that is all. All right, thank you guys. Thanks for watching. Goodbye.